All right, we're starting now. We're talking about the area. This whole chapter is talking about area. Wow, that's crazy looking. I thought I just fixed it. There we go. Now let's try it. That's better. All right, so we're doing area. Area of all kinds of stuff. Today's lesson is just two things. It's area of a parallelogram and area of a triangle, right? So let's go back in time when you were a kid. One of the very first things you found the area of. Do you remember? Yeah, square or rectangle. Ah, you probably didn't do circle right away, did you? I doubt it, because it was probably a while before you learned about pi and all that kind of stuff, right? Because you had to do pi for a circle. So it probably wasn't a circle. It was probably something like this. It was probably a rectangle, is what the first thing that you learn concerning area. Do you remember what that formula was when you very first time you learned it? How'd you learn it? Length times width is usually how it's taught. Would you agree? Okay, so most of the people say the area of a rectangle is the length times the width. We start doing triangle, we introduce another letter. We don't use length and width when we talk about a triangle. What do we use? Base and height. Okay, do you remember that? We'll talk about the equation in a second. We use base and height. You could also use that with rectangles, and in fact, that's what I'm going to do. You're going to rarely see in a geometry book the area equals the length times the width. Okay, we're going to use base and height. Now, this is a rectangle, so what kind of an angle is formed? It's a 90-degree angle. Okay, you follow me? So if I call this the base, which one is the height? Is it this one up here? Nah, it's the same size, isn't it? Okay, it's either this one or this one. Do you agree? So that would be the height. This is just review from back when you were a little kid. All right? I don't know, when did you learn this? Like 5th grade, something like that? 5th, 6th grade maybe? Probably at least 6th grade you know how to find the area of something. Would you agree? But I want you to see, the whole reason I'm talking about this is because I want you to see the relationship between the base and the height. If you have a rectangle, if this is the base and this is your height, why did I even do that? Because the base and the height have to be, what do you think? Give me a good geometry word. Perpendicular, that's right. The base and the height need to be perpendicular to each other, okay? Or they're not the base and the height. All right, so for instance, if I had, let me think. Let's do this real quick. Oops. Oh, come on. Grab it. There it is. Okay. It's not that easy. Kelsey, you paying attention? Yep. Simba. Are you Simba or are you...
Yeah. Oh, you feel orange?
Alright. Shh. We are. Thanks for paying attention. I cut my own hair. I always cut my hair. And I did give myself a haircut, yes. Thanks for noticing. Alright. Let's do this. Watch this. I'm going to take this rectangle and I'm going to make it look a little different. I'm going to make it look so it's not a rectangle. Watch. I hit this thing right here and I don't know, just make it like 20 degrees. See what that looks like. Yep. Oh, look at that. See how fancy that is? Now it's not a rectangle, is it? What is it? It's a parallelogram. We had a whole entire chapter, didn't we, on parallelogram, so you should recognize that. Now let's take a look at this. Everybody watching? A little talkative today. Let's pay attention. So if this is the base right here, would I consider that to be the height? Why not? It's not perpendicular. Absolutely right. So what we have to do is we have to, good, that's a good way to say it, drop a perpendicular. Where do we drop it from? Or from where do we drop it, right? You're not supposed to end a preposition, right? So it could be anywhere along here. It doesn't really make any difference because look, what's true about this side and this side right here? They are, it's a parallelogram, so they are what to each other? They're parallel to each other. So if I go here and I drop a perpendicular, I'm going to get the same exact height for there as I would if I dropped it from here. Wouldn't you agree? Those two would be the same exact height. So it doesn't really matter where on here you drop it from. I could take it from the corner. You're going to see that in a little bit. We're going to do an example. Let's pay attention, please. You could do it on the outside, but what would you have to do to this side right here? You'd have to extend it out, and then you could drop it straight down. You absolutely could, and that would be fine too. All right, I'm going to stick with inside of here, if that's okay. All right, so these could be, either one of these would be the height, right? That would be the height, that would be the height, this would be the base. Now, why did I make this the height, and why wasn't this the height? Because this one is what? Give me the word again. Perpendicular, okay? They have to be perpendicular. Make sense? So watch, this is kind of nice. On a rectangle, we said area was length times width. But if I call the two sides base and height, what would I call this? I'd say the area of a rectangle is what? Base times the height, correct? All right, that's on a rectangle. And you say, well, that's a rectangle. It's 90 degrees, so parallelogram must be different. Well, it's really not. The area or the formula for area is exactly the same. I'm going to write the word area out. The area is equal to the base times the height. But you got to be careful. A lot of people get confused and say, oh, it's just the two sides multiplied together. That's the height, that's the base. Well, it's not. This is the height. That perpendicular distance is the height. You with me? All right, so that's something that you probably didn't learn in 6th grade, talking about perpendicular and all that kind of stuff, but that's one thing that you need to see. Let's do an example with this. Hopefully it'll make some sense. All right, here's our picture, and we're going to find two things. Now, we just talked about area, but I'm going to introduce another word to you, but we don't really have to learn some kind of fancy formula to it, and you've probably already talked about this before, but it's called the perimeter. That's a fancy word? You've never heard that before? Okay, the perimeter. If I say walk the perimeter of the campus, or walk the perimeter of this, or you ever watch a war movie and they're like scoping out looking for the enemy and they're like, you take the perimeter. What does that mean? You take the what? The outside of it, okay? You're taking the outside. You're walking around the whole outside of this thing. So if I say find the perimeter of something, I'm talking about everything on the outside of here, okay? You're just walking around the whole thing. Another word that I use, I just say to find the perimeter is the distance around. You don't have to learn some kind of fancy formula to memorize. You just realize that it's just the distance around an object. That's the perimeter. You follow me? So if I wanted to find the perimeter of this, then I would just start at A, walk here, walk down, walk across, walk back up again. What do I do to all those lengths? If I want to find the perimeter, the total distance, add them up. That's all right. Add them all up, okay? So I don't know all the distances. I know that's 10. What about this one right up here? What do I do to that AB? Remember, it's a parallelogram. They tell you it's a parallelogram. It's 4, right? Because look down here. The opposite sides are equal to each other. We learned that about parallelograms. So that's 4. What about BC? What's BC? It's 10, all right? Now watch. It's hardly any work at all for this, isn't it? If I add up all the distances around,
28.
it's 28, right? 10 and 10 is 20, 4 and 4 is 8. So I'm not even going to show that. I'm just going to say 28. Now it is in inches, so do I just leave it inches or make it something crazier or what? Just leave it inches, right? It's length, it's distance, okay? Distance is just in inches. It's not squared, it's not cubes, not anything like that, okay? It's just in inches. You with me? That's easy. That's the perimeter. You don't, now some books will throw out formulas. They'll say, the perimeter of a rectangle is 2L plus 2W, and kids are sitting there thinking, okay, 2L plus 2W. But it doesn't make any sense to learn formulas like that, because I just think, just add up all the lengths and add up the widths, right? Add up all the sides. That's all you do for perimeter. You with me on that? Doesn't that make sense? Instead of learning all these new equations, then it gets people confused. The perimeter is just the distance around the whole thing. No big deal. Now, let's find the area. Oops. Area. Well, this is a parallelogram. Remember what the area of a parallelogram is. It's the base times the what? Times the height. Now, what has to be true about the base and the height, though? They got to be perpendicular. Do you see anything in here that's perpendicular? By the way, they said that was perpendicular. I forgot to put that in there. Okay? Do you see anything that's perpendicular now? Yeah, you do. You see this thing right here. So that's perpendicular. So which one is the base and which one is the height? Yeah, I would say the base is 10 and the height would be 5, wouldn't you? Okay, because that's part of the figure right here. So this is 10. From B all the way to C is 10. It doesn't stop at E. Okay, it goes all the way to C is 10. And this part right here is 5. So watch. All we do is just go the base times the height. The base is 10 and the height is 5. So that is 50. Now, we do have units here. This is in inches. Do we just put 50 inches? And that's the area? No, because what was 10? 10 was in inches. 5 was in inches. What's inches times inches? Inches squared. So our units are going to be inches squared. Now, some people might write it like this. They might write square inches. And that's fine. You'll see that all the time. I don't know if your parents ever go to get carpet or something like that for the house. You'll see it measured in square feet. And you'll see this. SQ and then FT period. Okay, square feet. But this is a little bit more mathematical. That looks just a little bit more concise, a little bit nicer. So I just write it just like that. We good with that? All right. Now we're going to do one that's a little bit more difficult. All right. And this was This was just given to you. I mean, they told you the height. They told you the base. I mean, there wasn't anything to that. Right? That was like way too easy. Wouldn't you agree? I want to be challenged, don't you? A little bit? Sure you do.
I like
Yes. You'd rather stick with this? Okay. Yeah, I bet you'll like this next thing. So let's do another one where it's not so easy to find the height. Okay, it's not as easy as this one, I should say. All right, let's see what we can do with that.